Hello everyone, I'm Norman Wildberger. We're talking about the sociology of physics, and today we're going to try to let go of inertial reference frames in special relativity. So this is a core concept which ultimately really in some sense goes back to the Newtonian point of view with the initiation of the mechanics that revolutionized our modern world. But it was also taken on board by Albert Einstein, but modified suitably. And it's now sort of a standard framework that physicists universally use to talk about how we set up mechanisms to measure motion, interaction, dynamics, etc. So I think, however, that unfortunately this idea is past its use-by date, and that we need to adopt actually more modest and realistic approach to our position in the world, especially when we're trying to tackle large-scale issues, as we do when we are looking at special relativity and then later on general relativity. So I'm going to restrict the discussion to one-dimensional physics, which is quite a dramatic simplification. So there's special things that happen in one dimension, or maybe we could say there's certain things that happen in higher dimensions that don't happen in one dimension. That simplifies the situation. But nevertheless, this is a good place. It's kind of a laboratory for getting fundamental understanding. So here's a one-dimensional space, whatever that sort of means, and we're imagining that we have some observers, say A, B, and C, and they're moving in an inertial fashion. And that means that they don't feel any kind of local accelerations. If they send a little piece of rice on their spaceship floating across the cabin, then it'll just float in a straight line. It's not going to be pulled in one side or the other or speed up. So these are inertial frames. That's sort of the setup for special relativity, as we've discussed before. And we're also going to allow them to have clocks. Okay, so the clocks are calibrated in terms of a back and forth signal. And it could be light. Traditionally, it's light. But as I've argued in other places, sound actually, to a large extent, works just as well in terms of trying to understand what's really going on. And in fact, if you are interested in this topic, over at Wild Egg Maths, I have a series called Classical to Quantum, where I'm going to be delving into mathematics of what I think is quite a simplified way of thinking about special relativity, where actually the sound is sort of put center stage to clarify what's really going on. Okay, and the idea is that these observers are interested in events and interested in making measurements and making deductions about the world. And in order to do that, they are going to be sending light signals or receiving light signals or sound signals or whatever signals there are. And then there's an attempt to try to assign time and space coordinates to these various events. So that's the general setup of special relativity. And it's, in some sense, quite following Newton's original setup in the Principia, where he sort of starts modern mechanics with his laws of motion. Now, Newton takes the position that there is an absolute fixed space and time. So there's a kind of a God-given X coordinate system, which represents the spatial direction in this one-dimensional situation. And there's a God-given coordinate direction called T, which represents the time direction. And an event E is represented in this world by a point in this two-dimensional space-time. So that point there would have space coordinate 3 and time coordinate 2. And I'm putting G here because perhaps we could think about this as being almost an omniscient observer, almost perhaps outside the system, who is able to see everything in a fixed, sort of standard way. However, this position is quite at odds with Galileo's invariance principle. So there is some tension, even in the 17th century, there was some potential tension between Newton's new development and this original understanding of Galileo that, in fact, the laws of physics are invariant under uniform motion. And in particular, as Galileo says very explicitly, it's impossible to tell if you're on a ship on the ocean whether you're actually moving or not moving. If you're enclosed in the cabin, you can't look outside, and the uniform motion is very smooth. Okay, so nothing that you do inside the cabin in terms of creating physical experiments and performing various things, even biological things with bats and birds flying around. None of that is going to help you in determining whether you are actually in motion or not. And that has the implication that the idea of being at rest, okay, is really not something that we can get our hands on directly as participants in the universe. Okay. And then Einstein comes along, and motivated actually not by thinking about mechanics, but rather by thinking about electromagnetism and Maxwell's equations and various consistency issues that arose there, he comes up with this modified point of view. So in this one-dimensional way, we could describe Einstein's understanding perhaps as this. So Einstein posits what's called now an inertial reference frame, which you can think of in this one-dimensional setting as something like this, okay? So maybe here where I'm holding it, that's where the observer is. Maybe that's like a spaceship there. And along this one-dimensional world, there are equally spaced points. So you can think of these as identical rods that extend in both directions. And actually Einstein posits that there are clocks at all of these positions, and actually friendly observers also at all of these positions. And it's then this combination of having the space laid out in this one-dimensional fashion with these rods and having time laid out with these clocks that basically is a way of sort of replicating Newton's two-dimensional space-time world in this one-dimensional fashion. But crucially for Einstein, Einstein takes the point of view of Galileo, essentially, and says, well, actually, there could be such a system for more than one observer. So A could have a system like this, and B could have another system. And they could be moving with respect to each other. And just as Galileo said, Einstein posits that we can't tell which one is absolutely at rest, which one's absolutely in motion. So in contrary to Newtonian point of view, this is more a Galilean point of view. However, there's something to be said about the setup of these clocks. So Einstein posits that these clocks that are regularly spaced along here are calibrated in a certain fashion, and the calibration is done by the observer at this point here sending out light signals and measuring when they come back and making certain having the observers at all these places make adjustments to their clocks so that they're calibrated in a natural way with the clock at A. Okay, so it's a kind of a calibrated coordinate system of clocks. Now, as I've explained in other places, the way Einstein actually sets up the calibration actually renders these clocks and actually these observers also to a large extent unnecessary. So you could actually dispense with all of these clocks and just observe events, like if something happens here at some particular point, then that could be observed by having sent out a light signal and having it bounce off there at exactly the time when the event occurred, and then having it come back. And then if A has a clock, which we're assuming he does have here, then he can make some kind of measurement and calculation depending on the initial and final times of this returning light signal to deduce what the time and space coordinate of that event was. Okay? So that's the basic setup. And this whole thing here, this idea, this conceptual framework is called an inertial reference frame. And it's sort of the workhorse of how modern texts and courses on special relativity set things up in the first place. But I think there's some serious problems with this. First of all, I think that Einstein has gone sort of halfway. Right? He's taken this two-dimensional sort of fixed point of view of Newton, which we might represent like this. Well, there should be another one there. So that's some kind of space-time, right? And replaced it somehow with a one-dimensional system like this, suitably calibrated. But so what he's done is he's finessed the clocks, okay, finesse the idea of having some sort of universal time as Newton does. But he has not finessed the idea of having a prior fixed, rigid network of equally spaced rods. Okay? And that's a problem, because like, how are you going to make such a system? Let's say you're trying to do this in practice, okay? So you have to have some factory, perhaps here, where you create a lot of these identical rods, fine. And then you have, let's say they're all a kilometer long, and then you send them up in your spaceship, okay? And so you have these kilometer long rods, and you're going to attach them, weld them together, okay? But to get them in the various places, you're going to have to accelerate them, and you're going to then have to decelerate them and then put them in place. And that might be fine if you're talking in a local kind of fashion. But if you're imagining that this inertial reference frame is the coordinate system that you're going to use to understand the cosmos, so that in principle it goes beyond the solar system, into the galaxy, perhaps even beyond the galaxy, then you have to confront the reality that you're not going to be able to do that. And if you were going to try to do that, then you have an issue with significant accelerations and decelerations of these rods, which were initially the same, okay? But by the time they've gotten, a million light years over here, perhaps they are no longer the same. And so I'm of the view that this setup, this assumption, okay, that we are able to think about having these equally spaced rods is in some sense, it's already somehow against the underlying spirit of relativity, okay? Because you're assuming that what you can do here is very much the same as what you're doing very, very far away. The fact that you've moved something very, very, very far away, that still it's the same in some fundamental way, okay? That's at odds, I think, with the general principle of special relativity. So what's my take on the story? So I think the more fundamental and natural point of view, even though it may seem weaker, is to have a much more modest understanding. And that is encoded by the following. Okay? So in my view, we have an observer. We'll give this observer a name, A, okay? And it's represented by this, okay? So instead of this, or instead of Newton's fixed spacetime, instead of Einstein's inertial reference frame, we just have a single observer. This is really the way we are in the world. We are here on planet Earth, just a small little speck in our solar system, which is just a speck in the galaxy, which is just a speck in the universe at large. Okay? And ultimately, all the information that we have is obtained by sending some electromagnetic signals out in our local environment. Maybe we can get to Venus and bounce things off Venus or Mars, but not too much further than that. And then also, of course, ingesting information of electromagnetic radiation coming in from distant places. But ultimately, the correct sort of orientation is to have a modest one, that all what we really have is this point position and our wits to try to interpret what's the significance and the meaning of these various signals that are coming to us. So to a first, in the local environment, yes, we are able to send out signals, like here, okay? We send out some signal and it returns, or maybe in this direction, okay? But if we zoom out, then even this capability is really not there. And all what we really have, if we really zoom out, is just light signals coming in from distant places. And it's with this information that we have to try to piece together the story of how we really are. So anyway, so in my take on special relativity, we abandon inertial reference frames. We deem them not necessary. I claim that pretty well everything can be accomplished just by having this much more modest point of view, We're not making additional assumptions about creating some gigantic framework of equally spaced rods extending into the galaxy. No, we are just facing the reality that we are little creatures on some little ball in some vast cosmos, and we have to figure things out accepting that fact. I'm Norman Wildberger. Thanks for listening.